Okay, so we're talking equivalent expressions. This is a simpler one, but we want to see if they are equivalent. How would I do that? There's a couple different ways that you can do that. You can substitute, or, well, we're not solving. These are not equations. We can simplify. You simplify equations, okay? Equations, and this is another thing, just a definition of expression. Expressions can be variables. They can be numbers. They can be operators like addition, subtraction, multiplication, division, but no equal sign, okay? So we simplify expressions, and some of you are saying solve a lot. Simplify expressions. We do not solve. We do not want to set these equal to each other either, okay? But the two things we can do is substitute a value in, okay, and see if they are equal, if they are the same. And two, we need to try to simplify to see if we would get the same result. So either one of these, okay? So if you put in, and this is why you have to sometimes do this a couple of times, I don't know, give me a value. X is equal to what? 2. So if x is equal to 2, over here we get 2 plus 1, which is 3. 3 times 3 gives us 9. Over here, 3 times 2 plus 1 gives us 6 plus 1, which is 7. So they are not the same. These would not be equivalent. We substituted x equals 2. Did I do something wrong? X is 2. I said just give me a value. 2 plus 1 is 3. And 3 times 3 is 9. I very likely could have made a mistake. I got less than 4 hours last night. So, and over here, 9, 7, they are not equivalent. I know. I had a big event yesterday, and I chaperoned, and I went to the game. I know, and I had a big event yesterday. Yeah. The other thing is to simplify. So if I simplify this by distributing, what would you get? 3 times x is 3x plus 3. Is that the same as 3x plus 1? Well, if you subtract, let's see, I say you shouldn't set them equal, but you end up with 3 does not equal 1. But you do try to simplify. 3x plus 3 is never going to be the same as 3x plus 1. Not the same. Okay? So you either substitute a value to see if they are equivalent, or you need to simplify. Now, let me show you one thing that people try to simplify with that is not good. I remember from the homework, somebody had something like is x equivalent to x divided by x minus 2? Are these equivalent? Well, first of all, you could substitute values. That's one of our options, right? If I substitute a value, let's put in 1. Here I get 1. Here I get 1 divided by 1 minus 2, which is 1 divided by negative 1, which is negative 1. So they're not the same. So they are not equivalent. And you could put in other values. You might have to put in a couple, because there might be a value for which that might work. Probably not, though. Well, if I do 0, X is 0, and if I say 0 divided by 0 minus 2, I get 0 over negative 2, which is 0. So you might have to do a couple, because usually if it's a sometimes, which is another part of this test that we will have, you might want to double check. If you find one that's not, see if you can find one that is and does make it work. But some of you were trying to say that this X, I wanted it blue, and that you would take this divided by this and make that 1. You cannot do that. You can do it if you have only one thing on the bottom. Yes, you can say this is X divided by X minus 2 divided by X. That's only when you have one thing in the denominator. But if you have two, this division sign here separates this and makes this where it has to stick together. Okay? So you cannot simplify this to 1 minus X over 2. It is not the same as X divided by X minus X over 2. It does not work. It does work if you have one thing in the denominator. Questions? Katie's like, is it a little much?
Yep.
Huh?
Would you be able to organize it better? Like, it just looks a little messy.
I know, that's how I am. Well, I'm just doing this kind of off the top of my head, just because I noticed in some of your homework. I mean, I am recording this. So you can go back and watch it as slowly or as quickly as you want. Let's talk about equivalent equations. So equivalent equations, and this isn't even part of our lesson. Like I said, I just noticed this and want to make sure that we understand what we're doing here. First of all, equations are, what are equations? Okay, yeah, basically it is two expressions set equal to each other. So you do have to have that equal sign. Two expressions set equal to each other. So equivalent equations might be something like 4 times x minus 2. Is that equal to 4x minus 2? Okay. So how would you start to check for whether they are equivalent here or not? Okay. Simplify the left side. It's okay to say simplify the left side because that is an expression. This in of itself is an expression. So if I simplify that, I can't do what's in parentheses. You would need to distribute. And you're going to get 4x minus 8 equals 4x minus 2. Subtract the 4 x's. And you're like, wait, that gets rid of the x. Yeah? And you're left with negative 8 is equal to negative 2. Is that ever going to be possible? No. So these are not equivalent. Okay? If you have something like 5 divided by x minus 2 equals 3. Shoot. Actually, I didn't do that right, did I? Because that's not two equations. See, that's what happens when I do it off the top of my head. So, okay, what if I would have said 4x minus 2 equals I don't know, negative 3? Is that the same as 4 times x minus 2 equals negative 3? But you still, here you would have tried to solve, and if you would have gotten different answers, then that would tell you they're not equivalent. So that was my mistake here. These I did set equal to each other, but they're not equations, period. This is an equation when I put them together, but they weren't two separate equations.
Okay. Is that what we're doing today?
No, it is not what we're doing
Okay,
today.
that's what we already did.
Yes, this is what we've already done. So this, I would say, is this equation equivalent to this? What you would need to do here to check is to try and solve. Try to solve for x. We don't like having x in the denominator, so I would multiply by x minus 2 over 1 and multiply over here, x minus 2 over 1. These would simplify out, and you get 5 equals 3 times x minus 2. And if you multiply that out, you get 3 times x minus 3 times 2 is 6. Is this equal to this? Yes. So these, yes, are equivalent. Or if you end up with something that says, and you solve it down for x, and you get x equals 3, and you solve the other one and you get x equals 3, then yes, they are equivalent. Okay? Questions on that? You can look back in your notes too. Always look back in your notes. All right, let's go to page 51. This is a good problem. This is a challenging problem, I will say though. Why do you always think the challenging problems are good problems, Miss Dede? I don't know. Because I like problems that make you think. Talking about basketball. Some of you play regularly. Yeah, we don't like this x down here, so multiply by 30 plus x. Multiply this side, 30 plus x. These simplify out. Always running out of room. And I get 18 plus x equals 0.75 times 30 is going to be, what is it? 22.5 plus 0.75x. Now, it's important to know how to do the algebra here, too. All right. Can I combine like terms on the same side of the equation? No. Let's get our x's to one side. So I'm going to subtract 0.75x, subtract 0.75x. Remember, this is a 1 understood. Those cancel out. I get 0.25x equals, now I'm going to move this 18 to the other side by subtracting. By subtracting, 18s cancel out, and I get, what is it, 4.5? Divide by 0.25, divide by 0.25. X is equal to 13? 18. 18 what? Games. And they are games, but they are also winning games for Chase. So that's what we would do to figure that out, because the number of winning games is the number I have to add to the total at the same time. So now, hopefully, you can do B on your own. It says, how many games would Chase have to win in a row to have a 90% winning record? 90% winning record. Take 2 minutes, see if you can write down the equation at least, and then we'll go over it. Are you just doing guess and check?
Basically.
Do you understand what I'm doing up here?
Maybe, probably.
Yes. I'm glad you can do that, but you should.
I mean, yeah.
You're adding the same variable to both numerator and denominator to get your winning percentage as a decimal. Everybody should be working on B. B. Kylil, come on. Come on, guys. About another minute. I forget what the third question is. That's a good question. Okay, who wants to give me the Wait. How about the equation? You can give me the equation, can't you? Wait. What? 36 plus x. I've never done it that way. I think you're saying 36 plus x divided by 48 plus x? Is that what you said? I don't think it would be 66. Here's what I would do. So start with, did you have it? What did you write down? A little bit louder. Yeah, that should be your new equation. I think you could start by adding the 18 and going from there, but this is probably safer, but I think yours would work. So it's the same. We started off with the, what was it, 60%? Yeah, 60% winning average. We added the same amount of winning to the numerator and the denominator, but this time we made it equal to 0.9. So we don't like this in the denominator. Multiply by 30 plus x over 1. Multiply by 30 plus x over 1. These cancel out. 18 plus x is equal to 90% of that is 27 plus 0.9x. Get your x's to one side. Hopefully the larger side. Remember, this is 1x. Subtract. So I get 0.10x. Move this 18 to the other side. Subtract 18. Subtract 18 equals 9. Divide by 1/10. And that is equal to, x is equal to 90 games. Whoever's got the music on, it's too loud and rude. X is equal to 90 games. So he would have to win 90 more games in a row against his brother for a 90% winning record. Questions on those two? All right, let's take a look at C. Is Chase able to reach a 100% winning record? Why or why not? How could I solve it algebraically?
No, you can't get 100% winner
Why not?
because he had already lost those games.
Excellent thinking. No, he already lost some games. You can't win 100% if you've already lost some games. Okay? But if I wanted to try to figure it out algebraically, how would I set up that equation? What was the first number? I forget. 16? 18? 18 plus x equals, we set it as a decimal, so 100% as a decimal is what? 1. And you could solve that and simplify that. Okay? I'm not going to do that. I think most of you see this right here, though. Okay? He would not. Every time he's going to get closer and closer and higher, but since he's already lost some games, he's never going to get to 100%. Last question. Suppose that after reaching a winning record of 90%, Chase has a losing streak. How many games in a row would Chase have to lose in order to drop down to a winning record below 55%? Too much. Is this an equation? Yeah. It should be an inequality because it says we want a winning record below 55%. So on the right-hand side, we're going to have less than 0.55 because we want it to be below 55%. Okay, what am I going to have on the right or the left-hand side? $108. Is that after adding 90? And then you said what? Did you have plus X here? 108 over 120 plus X. Question. Why does she not have the plus x up here? That's right. This up here is the winning amount. This is the winning amount. Okay? We don't want to add games that he lost. So that's why the 108 stays the same. But the number that he lost is going to increase by some amount that we don't know. So here we would multiply 120 plus x, 120 plus x. These cancel out. I get 108 is less than, oh, that's an 8. 0.55 times 120. What is it? I'm just trying to check my notes. Yes. 66 plus 0.55x. Subtract your 66, subtract 66. We get 42 is less than 0.55x. Divide by 0.55. X. We didn't divide by a negative, so my sign's going to stay the same. X is greater than 20 or 76.36, something like that. So X has to be greater than 76.36. What does X represent here? A game. Can we have 36 hundredths of a game? No. So if that has to be greater than that, it needs to go to 77 games or more. Okay? All right. Hey, we had some good thinkers in here. Now, some of you might not be totally up to speed. That's okay. There is not a problem this difficult, I would say, on the test. But I like it because it makes you think. Finish up your homework and we'll be back tomorrow. Thank you.